Hello everyone, my name is Arya Devdar and this is part 4 of NCERT Class 10 Science Chapter 2 Acids, Bases and Salts. Right? So in the last part we covered some remaining reactions, right? We proved that metallic oxides are bases and non-metallic oxides are acids. And we also saw the differentiation of ions in acids and bases. So we saw that acids produce H plus ions or hydronium ions, right? And bases produce OH minus or hydroxide ions in when they are mixed with water, correct? So in this part, we are going to continue. Now in this part, we are going to start with pH. So we are going to see what is pH, everything, the definition, the full form, everything, right? So we are going to see what is pH. After that, we are going to see the strength of acids and bases, right? So I'm going to differentiate between strong acids and strong bases and weak acids and weak bases, right? So I'm going to give you a table which will help you, right? Okay. And next, we are going to see the importance of pH in everyday life. So this part is all about pH basically. Importance of pH in everyday life. Correct? And lastly, we are going to see some naturally occurring acids. So there is a table given in NCERT. I'll just discuss that and I'll add on a few more of my own, right? Some naturally occurring acids. Okay. So let's start with the first question. What exactly is pH? Okay. So up till now, we have seen that acid-base indicators, they are used to distinguish between an acid and a base. Right? We have also seen the differentiation of ions, H plus in acids, OH minus in bases, right? But now, the scientists, like when they were discovering all of this, they wondered that is there a way, a scientific way, to measure the amount of H plus ions present in a particular acid or a base? Right. So how can we measure it? So can we find out the amount of these ions? Right. So this is why they have developed pH or the pH scale. Right. So basically the full form of pH. So it is originated from German. It means potens. So P of pH, it means potens in German. So basically, pH, it is the potential of hydrogen. Potential or slash power of hydrogen. Hydrogen in the sense I mean to say H plus ions. Right? So that is basically what is pH. Okay. So a scale which for measuring hydrogen ion concentration in a solution is called the pH scale. I'll write it down. A scale used for measuring hydrogen H plus ion concentration in a solution. It is known as the pH scale. Correct? Simple, right? Okay, so that is what pH is, right? Now we have seen that acids and bases, they are distinguished by indicators. So now which indicator do we use for this universal purpose, right? So obviously we use the universal indicator, right? So this universal indicator, it is a mixture of very many indicators. Okay, several indicators together, they are mixed to form the universal indicator, right? And this universal indicator shows different colors for different levels of hydrogen present, right? So basically a pH scale, it ranges from 0 to 40. 0, it means very acidic, okay, and 14, it means very basic, highly acidic, or strongly acidic, strongly basic, anyway. Okay, so very acidic, 0 is very acidic and 14 is very basic. Okay, so acids are usually denoted by a red color, right? So the scale goes from red to green, or yeah, to green and then to blue or purple, right? So This is basically sort of purplish. Okay, very basic. So I have a picture here from your NCERT itself, right? So this is the picture of the pH scale given in your NCERT, the diagram of the pH scale, right? So as you can see, 0 is very acidic. 0 can be said for HCl, hydrochloric acid, right? Now gastric juice, it is 1. Again, very acidic. 0 to 1, very acidic. Okay, from 2 to 6, I'll say mildly acidic. Okay, mildly acidic, right? So lemon juice is 2.2. Okay, still more acidic than maybe acetic acid. So acetic acid lies here, right? Somewhere. I'll give you the pH of some important compounds, but later. For now, just understand the scale, right? And 7. 7 is the distinguishing factor. 7 means neutral. 7 is neutral. So distilled water or distilled water or blood, approximately it is 7. Okay, pure water. Blood is a bit more alkaline, it is 7.4 as it is given. Okay, but pure water, distilled water, it is exactly 7. And then from 18 to say 11 or 10, 18, I'm sorry, 8 to 11 or 8 to 10, this is mildly basic, mildly weak basis, right? And from 12 or 13 to 14, very highly basic. So here sodium hydroxide, NaOH, comes. NaOH is highly basic, right? It is a corrosive material. As I told you last time, the dilution, if it is done wrongly, it can cause very harmful burns, right? So NaOH, HCl, all of these, they are very harmful, right? And they are very strong acids and bases. Okay, right? So as I said, the pH of a neutral solution is 7. Values less than 7 on the pH scale represent acidic solution. And as this pH scale, it increases from 7 to 14, they represent bases. Correct? So I'll write this down in short here. For acids, the pH should be less than 7. For neutral, pH should be equal to 7. And for bases, pH should be greater than 7. Sorry. Yeah, there we go. Okay. So this is the basic differentiation. Okay. So now understand this even more. Let us understand this even more. Here, acids, right? So very strong acids, they will have a very high H plus ion concentration. Agreed? Right? So here the H plus ion concentration, it is maximum at 0. Okay. And this goes on decreasing from 0 to 14. The H plus ion concentration. It goes on decreasing from 0 to 14. Similarly, here at 14, the OH minus ion concentration is maximum, right? And this goes on decreasing from 14 to 0. OH minus ion concentration. Okay. So you understood this. This is very important. You have to understand this. From 0 to 14, the H plus ion concentration, it goes on decreasing, right? So from this we can conclude that bases, they also contain a small amount of H plus ions. They also contain small amounts of H plus ions, but the OH minus ions, they dominate the H plus ions in bases. In acids also contain OH minus ions, but the H plus ions, they dominate the presence of OH minus. So we do not consider it. But you should know that it is like present. Okay. It's not completely 0. Maybe in sodium hydroxide, it might be very close to 0, the H plus ion concentration, but it is not 0. Okay. So basically from 7, right? From 7 towards this side, acidic nature or acidic nature increases. And towards this side, basic nature increases, basic strength increases, whichever. Correct? So this is like the analyzation or interpretation of this graph or diagram. Correct? So basically, a universal indicator is used to find this. So a paper which has the drops of universal indicator, right? It is used to find the pH of solutions. And you have like this pH color scale on your the sheet of universal indicator paper, right? So it is of yellow color usually, okay, like a very pale yellow color. So it changes the color according to how acidic or how basic it is, the solution is. Okay, so basically paper which contains the drops of universal indicator, it is used for measuring pH. So I'll write that down here. Universal indicator is used for measuring pH scale. Measuring pH scale. Okay, so potence of hydrogen or potential or power of hydrogen. Understood? So this, so that I have explained the variation of pH with the change in concentration of the ions, the H plus ions and the OH minus ions, right? So now let us see some important pH values, right? So some of them are already given here, as you can see. Gastric juice is given, right? And lemon juice is given. Gastric juice is very, very acidic. Okay, about 1.2. Lemon juice, it is 2.2. Pure water is 7 exactly. Blood is 7.4-ish. Okay, it is a bit alkaline, slightly alkaline. Milk of magnesia, which is MgOH twice, it is 10. So it is mildly basic. Okay, and sodium hydroxide, highly acidic. I'm sorry, highly basic, NaOH, right? Okay, so yeah, let's see some more here, right? So the first one, so HCl, it has not exact, it will be between 0 and 1. So you can write 0.5 for HCl. Okay, so I'll write it here. HCl has approximately 0.5 or 1. Okay, the strongest acid, it is sulfuric acid. Sulfuric acid, H2SO4, it has the highest pH, probably of 0.1 or 0.2. Okay, very acidic. Okay, highly corrosive. Correct? Lemon juice, as it is written, 2.2. Okay, vinegar, that is acetic acid. Acetic acid, it is about 2.5 approximately. Okay, I'm giving you approximate. This is CH3COOH, ethanoic acid or vinegar, whichever one you want to call it. Correct? The carbonated beverages which are present, right? Carbonated, so soda, like soda water, right? Basically Sprite or Coke or whatever you drink. So carbonated drinks, they are acidic. Okay, so they are about, you can say, uh, 2.53. Okay, so they are highly, like mildly acidic, and we still drink it. Okay, then we have acid rain. So we'll learn more about this in the everyday life pH values, right? But acid rain ranges approximately 5.6. Okay, 5.6. Pure rain is also acidic, but not very acidic. So pure rain will range somewhere between 6.5, maybe 6.5 or to 7, right? Pure rain. Okay, so this is the acid side. Okay, now I'll tell you about the basic side. What all is there in bases, right? So in bases we have, so for 7, there is freshly distilled water, blood, tears, all of that, they constitute that 7 to 7.5 approximately a range. Okay, after that milk of magnesia already given, it is 10, correct? Now the ammonia, household ammonia which is used, right? it is NH3, right? Its pH is quite high. It is 11.5 or 11.2 approximately. Okay, ammonia. The household bleach which is present, bleach, right? Bleaching powder, bleach which we use, which is NaClO. Not bleaching powder, a bleach, not bleaching powder. Household bleach. That is also very high. It is 12.7 approximately. Bleaching powder. Okay, very high. Okay. And the NaOH, it is 14. Correct? So bases there is not much, but for acids you have to remember some of these. It is very important. Understood? Okay. So saliva, one more thing. The saliva level, it is also 7 approximately. Right, so these are all the important acids and bases which you have to remember. The pH level, it can be asked approximately, right? Okay, now we'll move on to strong and weak acids and bases. So basically, the strength of acids and bases, it depends on the ion concentration, right? So increase in H plus ion concentration, that means the acidic strength will also increase. Acidic strength increases. Increase in OH minus ion concentration leads to basic strength increase. So this is the basic fundamental idea behind it. Correct? So H plus increase, acidic strength increase. OH minus increase, basic strength increase. Simple. Okay, now we'll see the list of strong acids, weak acids, and then strong bases, weak bases. So strong and weak acids, which are they? For strong acid C, we have HCl. I'm not writing the name, just the chemical formula, right? So we have HCl, H2SO4. HCl is hydrochloric acid, H2SO4 is sulfuric acid. Then we have HNO3, which is nitric acid. We have HClO3, which is HClO3, which is chloric acid. So I'll write this one. This is new. Chloric acid, right? And HI, this is hydroiodic acid. So as it was, HCl was hydrochloric acid, this is hydroiodic acid. Simple. Okay. Now weak acids, we have sulfurous acid, which is H2CO3. I'm sorry, H2SO3. Sorry. H2SO3, sulfurous acid. Remember, sulfurous acid. This is sulfuric acid. There's a difference. Sulfuric is strong, sulfurous is weak. Okay. We have a phosphoric acid. So I'll just write, you don't need to know the formulas, right? Phosphoric acid, basically it is H3PO4. Okay. We have acetic acid, CH3COOH, vinegar, right? Nitrous acid, HNO2, nitrous acid. This is nitric, HNO3 is nitric, HNO2 is nitrous. And we have methanoic acid. Okay, so this is the differentiation between strong and weak acids. Now we'll move on to bases. Okay, bases, the strong bases, first one, NaOH, obviously, right? Then we have KOH. NaOH is sodium hydroxide, KOH is potassium hydroxide. We have LiOH, lithium hydroxide. We have calcium hydroxide, COH twice. We have barium hydroxide, BaOH twice. Right? So these are all the strong. We have strontium hydroxide, which is SROH twice. All of these are very, very strong bases. All of these contain OH if you see, right? So I'll write this one. This is new, strontium. It is a element, right? Strontium hydroxide. Okay. Now we'll go to weak. Weak bases, we have ammonia. NH3, ammonia. Correct? Then we have sodium bicarbonate, which is NaHCO3, sodium bicarbonate, correct? NaHCO3, sodium bicarbonate. Then we have NH4OH, which is ammonium hydroxide. Ammonium hydroxide. Okay, so these are some examples of weak bases. Okay, strong and weak bases. So try to remember both of these tables. It will be useful for you, right? Even in your further studies in your higher classes. Okay, now we'll move on to the next topic, which is pH in everyday life. Okay, so this is an interesting topic. So basically, like, where do we use pH in our everyday life? Right, so there has to be some application. So this is basically application of pH. So the first one we'll see, it is plants and animals, or we can also say in our human bodies, right? Plants and animals. Okay, so our body, the human body, it works in a range of pH. So the range, it is 7.0 to 7.8. Okay, so slightly alkaline to neutral. That's the only range in which our human body works. If the range of our body, it goes beyond the given range, then it will be highly harmful for us, right? So basically, living organisms, they can only survive in a narrow range of pH change, right? There is not much space, right? Like there is not much difference between 7.0 and 7.8. Okay, so it's a very narrow range basically. Okay, now as I told you about acid rain, right, in the pH values, so when the pH value of normal rain, it changes to below 5.6, like less than 5.6, then it is called acid rain. Okay, so now when this acid rain, it flows down through the rivers and the oceans, then it also makes that water acidic, right? And hence aquatic life, they are also living organisms, right? So they also have a narrow range of pH. So when it becomes too acidic for them, they die. Okay, or they suffer side effects, or basically they die. Okay, one more interesting fact is that in Venus, right, the atmosphere of Venus, it is made up of uh, clouds of sulfuric acid gases. Okay, yellowish clouds, whitish and yellowish clouds of sulfuric acid. So basically life cannot exist there, like we cannot exist there, because the condition is highly acidic there. Okay, so that is why there is actually no living or organisms, or maybe no life yet discovered on Venus, or there is no life predicted on Venus. Okay, so okay, now we'll move on to the second part, which is pH of soil. Okay, so basically every soil has a different pH. Sandy soil, clay soil, your black soil, red soil, all of those, they have different pHs, right? And according to those pHs, the plants grow. Some of the plants, they require high or like high pHs. That means they require basic alkaline soil, right? Most of the plants actually, they require alkaline soil. Some of them also require acidic soil. So accordingly, you have to check the pH of your soil, right, in which your plants are growing, and give them the essential fertilizers. So if you need basic, more alkaline, then you can add more basic fertilizers. If you need more acidic, you can add acidic fertilizers, right? So hence you have to keep a check on the pH of your soil. Okay, the third one will go is about your digestive system. Okay, so now this is very interesting. So we know that in our digestive tract, in our stomach, hydrochloric acid is it is produced. So hydrochloric acid, as we have seen, it is a very corrosive acid. So then how does it not corrode the inside of our stomach, right? That is because of the mucus layer present inside of our stomach. It protects us from that acid, and that acid works harmoniously to kill all the bacteria present in our food, right? and hence it is good for our health, surprisingly, ironically. Okay, so now what happens sometimes is that when we eat too much acidic food, too much junk food, right, then the mucus layer, it starts to thin. Okay, and in certain places, if it thins too much, if it becomes very thin, then the acid, it will start to, corrode, or maybe it will start to affect the inside of your stomach, and that is what causes indigestion. Okay, indigestion. So during indigestion, we are what to say, we are advised to take some milk of magnesia or some antacids, right? Now these antacids or milk of magnesia, right, it contains bases, mild bases, not very strong, to neutralize the effect caused by the HCl, by hydrochloric acid, right? So milk of magnesia is MgOH twice. It is a mild base, right? So it can be used. It is a very good antacid actually. And other than that, many allopathy pills are also present, which also have the same like overall properties of basicity, but like they are also used for your indigestion problem. Correct? So these antacids, they neutralize the excess acid which has been formed to digest all the junk food, all the acidic food that we have eaten. Okay, so yeah. Now we'll move on. So this was about pH in digestive system. This is the third application, digestive tract or system. Right? Now we'll move on to the fourth one, which is pH change in tooth decay. Okay, so tooth decay, we know that the tooth enamel which is present, it starts decaying, right? It starts becoming black. So why does that happen? When you don't brush your teeth properly, or when you eat food, basically, the bacteria which are present in your mouth, right? They feed on the sugars or the food particles which are present or stuck in your teeth. Okay, and they produce acids. Okay, so a byproduct of the whatever the reaction takes place between bacteria and the acids, I'm sorry, bacteria and the sugars, an acid is produced, or many types of acids are produced. And the tooth enamel, which is made up of calcium hydroxyapatite, right? Hydroxyapatite, which is the hardest substance present in our body. Okay, it does not dissolve in anything, except it dissolves when the pH of the mouth is below 5.5. So very acidic basically for our body, right? So when it is below 5.5, which these acids produced by bacteria bring the pH down to 5.5, right? So then tooth decay starts. Okay, so that is why toothpaste is used. Right? Toothpaste contains mild bases, right? And when this is applied, or when we brush our teeth, then the toothpaste, it neutralizes the acids produced by the bacteria, and it also cleans our teeth. Right, so that is the way this the science behind tooth brushing our teeth works. That's why you should brush your teeth 2 times. Okay, yeah. So that is pH change as the cause of tooth decay. Okay. Next, we have also the topic of self-defense by animals and plants through chemical warfare. This is the heading given in your NCERT, and I really liked it. Chemical warfare. It's a very nice heading. Anyways, so basically, if you have been stung by a bee, sometimes you might know that it hurts, right? So why does it hurt? Because the stinger which the bee has, it contains methanoic acid. Methanoic acid is a mild acid, but it is still an acid, right? So it irritates our skin, and we wish to itch it, right? It causes an itching sensation, right? So that is their type of protection or self-defense, right? That is their way of defending themselves. So honeybees, right? And other than that, if you know much about plants, you might know this. Otherwise, ask your parents, they might know this, right? So nettle leaves are there. Okay, nettle leaves are grown, like they are sort of wild leaves, and they contain stinging hairs. Okay, on the surface of the leaf there are small hairs present. Okay, projections, and those projections, they also contain methanoic acid. So if you touch a stinging leaf, for instance, it will sting you and you will get irritation, maybe rashes or something. Okay, But the miraculous thing in this is that beside the nettle plant, usually a dock plant is found. Dock basically is a basic plant. Okay, so if you get stung by the nettle hairs, then you can use the dock plant leaf to rub it on your affected area, and you can relieve yourself of the pain. So that this is one of the wonders of nature. So nature also provides remedies, right? So exactly beside a nettle plant, a dock plant is usually present. Okay, so that was the last part of pH in everyday life. So we saw pH in digestive system, then pH in tooth decay. Correct? Remember the name of tooth enamel, it is calcium hydroxyapatite, right? It is a crystalline form of calcium phosphate. Okay, and other than that, when it goes below 5.5, then only degradation will start. Okay, and lastly, defense, self-defense by bees and nettle plant and dock plant also. Remember dock plant. Okay, so miracles basically. Okay, yeah. So now we'll go on to the last topic, which is some naturally occurring acids. Okay, so let's see them one by one. So vinegar contains acetic acid. Acetic acid, correct? Orange, lemon, all of these they contain citrus acid. Citrus acid, citrus fruits, right? Tamarind, you might have heard this. Tamarind, right? It contains tartaric acid. Tartaric acid. Then we have tomatoes. Tomatoes contain oxalic acid. Oxalic acid. Curd, right? Curd or milk, even it contains lactic acid. Lactic acid. Okay. Then we have, I'm sorry, this is not citrus, it is citric acid. Wrong name. Citric acid. Okay. And ant sting or nettle sting, both they contain methanoic acid. Okay. Methanoic acid. So you must understand one thing, that all of these acids which are present in like naturally, they are all mild acids. Okay, they are not strong. Strong acids are produced in the laboratory. Okay, these are all very weak mild acids, and some of them are also good for our health, especially these starting. They are very good for our health, right? We use them in our everyday cooking, or like we eat them directly, orange and curd and tomatoes, right? Okay, so that's it for this video. So we have completed the topic of pH in a very deep level, on a very deep level. Okay, so I hope you understood everything. I'll see you in the next part. Thank you so much.